So now I have the immense pleasure of introducing Frank Munz. He is a principal engineer at Databricks. He has written 3 computer science books, and he has also worked on a team that won a Nobel Prize. And he works on large-scale data and AI at Databricks. And he'll be talking about the serverless real-time Lakehouse. Welcome, Frank.
Thank you. Did I all put this in my CV, or did you Google that? All right, so thanks, everyone, for showing up. The title of the session is the Real-Time Serverless Lakehouse. The main part probably will be a live demo, so be prepared for that. And hang on. It all started, the whole idea for this talk actually started when I read an article from Google where they said, look, we can send you alerts if an earthquake is happening to your phone, but if you give us permission, we can also take the sensor data from your phone and analyze it offline. And when I read this, I thought like, wow, this is amazing for a couple of reasons, because it's crowdsourcing. I love all these crowdsourcing approaches. And then it's streaming data. And just imagine like how many times did you see the streaming keyword today, and how many times did you see real streaming data in any session, in any keynote? It's actually incredibly difficult to demo that. And even internally within Databricks, we talk about streaming data, and then we tell people, look, if you ingest from a file, from a folder, and you get more files, that's kind of streaming data because data is added incrementally. That's all true. But to simulate this, you need a lot of effort, and it's always like, it's always challenging now. So I thought like having this kind of streaming data would be fantastic. So it's moving fast. So I thought like, well, obviously it's easy for Google to build such a system, but I mean, they have all the resources in the world. They throw a lot of engineering resources at that and just build it. And I thought like, could I build this myself, just using Databricks technology? And this is what the talk is about. So what I wanted to do is, hang on. What I wanted to do is build something that basically lets you use your mobile phones as sensors, because, you know, did you get the notice to bring your phone? Yeah, everyone brought his phone. You always have your phone, no? So if you have your phone and it's shaking a lot, the expectation is that the system will pick it up, and that's not fake. That's actually real life demo. And the system will pick it up. It goes through the Wi-Fi here. It goes through a streaming data pipeline. It's analyzed with Spark structured streaming, and that's all the things I want to talk about. So I thought that's a really cool demo, isn't it? And that's actually me now doing movements with my phone. And obviously, you could say, now, well, I could do this with a little bit of JavaScript and draw beautiful diagrams. You can do it, but you can't do it at scale. So the scale is actually here more important than the latency. So I want to have like really, ideally, tens of millions of events per day. And that's what I want to talk about. So let's go back to this. And I missed one. That was a joke. Hang on. OK, no, don't laugh yet. So obviously, Databricks is the Lakehouse company. We kind of pioneered that data platform. And last year, I gave a more introductory talk about the Lakehouse, and I explained like why and everything. But the 3 takeaways is it's simple. It kind of unifies the data warehouse. It kind of unifies all the ML and scientific notebooks, the data science on the other side in one simple platform. And a lot of customers these days love this because it reduces the total cost of ownership. And the second part is where I want to go into more detail. It's open source, it's based on open standards and open source projects. And last year I was trying to explain to people like, look, this is why we have Spark, and this is why you would use Spark. And this year I understood like, hey, come on, you're in the Silicon Valley, you probably don't need to motivate like why you would use Spark. So the strategy for this year is just to spend like 5 minutes in the key 4 open source technologies and give you a update what happened within the last year. And last of all, it's multi-cloud. So if you're worried about, being bound to one cloud provider, you can just pick any one. Databricks is running on any of them. So the first technology I want to talk about is Apache Spark. And some people already laughed. That is good, because if you don't get the joke, and I have to explain, it doesn't get much better. While I do believe that there is a lot of beauty within Spark, I think the joke here is more about reach. It's more about popularity. So Spark got downloaded 1 billion times in the last year. That's an amazing number. Obviously, they're counting the Maven and the pip installs. Still, 1 billion times is an amazing number of downloads. It's 40,000 commits, and it's actually the top green line here that you see here. So it's the number one project with the highest activity in development in 10 years. And it's just constantly number one, not going down. And if you see all the other lines going up and down, you can guess what's happening there. Within Databricks, we kicked off a project. It's called Lightspeed. And the main goal was to get to sub-second latency for stateless pipelines. A lot of technical improvements for micro-batching, offset management. But everything here until being able to use enhanced fan-out from Kinesis if you ingest this to Spark. It's actually something I'm going to show you today. Something else that is new is Spark Connect. It's a client API, so it's a tiny bit that you run on the client that allows you to, for example, to use your notebooks together with a Spark cluster. We released a plugin for Visual Studio Code that was super, super popular. And so that's Spark Connect with a client API. Something else that is within this, we all talk about LLMs and AI, is there is an English SDK for Spark. So you can write English comments for Spark, and they're kind of converted into Spark code. Now, you could say, well, I could take the same English comment or English phrase and put it into ChatGPT, but ChatGPT is then trained with all the internet, which contains a lot of noise and a lot of rubbish. So using this will get you much better results. Last year, I also talked about Spark and how cool Spark is because it allows you to ingest, any kind of data format like CSV and Parquet, and then you can abstract it as a table, and you can run analytics on top of that table. But the whole beauty breaks down if you not try to just select from that table, but to update that table. And typically, you can't if you load this from a JSON or Parquet file. So you need some underlying data format. And Delta I/O is one of them. And it's actually a very cool one because if you have such a Delta table, and that's the topic of this session, you can stream to the table and you can also stream from the table. So the streaming in the data format, which is the core of the Databricks Lakehouse, is built in from the ground up. And that's what makes it very suitable for streaming. There's a huge ecosystem for connectors for Delta. And actually, it's so big that a lot of connectors use different approaches how to work with Delta I/O. We counted like 8 different approaches, and this is why we introduced the Delta kernel that is kind of this unified way of accessing Delta, which includes the data and the metadata. So it's a more unified way it's a way of guaranteeing that connectors are built in a more unified way. The other one is, I say Delta, a lot of people say, hey, but what about Iceberg? What about Hoodie? And I read this benchmark, and then actually we won a lot of these data format benchmarks. But still people think like, should I use this format or should I use that format? It was a huge discussion. So at the end, we decided, look, guys, it's all Parquet with a little bit of different metadata. We can write the Parquet and give you all the metadata, write the metadata as well. So there's Delta Uniform that basically writes Delta plus Hoodie plus Iceberg at the same time. So you should be able to read that from any other system, which is super cool. There's benchmarks because people say, hey, if you write more metadata than you have to, doesn't it cost performance? The initial measurements showed it's less than 5% of additional performance that this will cost. And we also did a benchmark using iceberg tables, and then the iceberg tables written from Delta Uniform, they performed 30% better than some other product that created iceberg tables. So at the end, it's like fantastic and doesn't cost you anything. Delta sharing is another open source technology that is built into the Lakehouse that we use a lot. I'm giving a lightning talk tomorrow at 3:30. It's a cool topic. It's an open source project. It's basically a server that you could run yourself as a Docker container, as a binary. It's built in the account if you have a Databricks account. So you can share your tables. You can actually even share streaming tables. And the cool thing is on the other end, on the receiving side, all you need is Python with pandas or Python with Spark. So any system can read it. And it's basically, well, any system being able to read pandas or Python, but there's also a huge ecosystem. And just recently, Twilio, Dell, Cloudflare, and Oracle announced it. So Oracle said, look, for our data warehouse, we want to be able to share our data in a platform-independent, open way. And they said, we're going to use open source Delta sharing for that. That was like a super cool announcement. I'm going to talk about this a little bit more tomorrow. Right, MLflow. So many things happened within MLflow in 1 year. You all got the message, like everyone is talking about these generative AI and LLMs. There is model serving now optimized for LLMs in MLflow, and I'm just picking out 2 features out of like so many that we announced this year. And because, it's 2 things. People want to create their own LLMs with their custom data, train or optimize their own LLMs. But still, they also want to call out to, ChatGPT 3.5 or 4.0. So for the first time, there's a lot of, call outs to other systems, to other APIs. And that's why actually customers said, look, we want to channel this. We want to be able to control this better. This is why MLflow now comes with an AI gateway for these call outs to better manage them. Right, now I told you that everyone could hack this little bit of JavaScript to make these bars scroll through. So I thought, like, why are not you trying the same thing that I tried? And to do this, I'm going to show you how this looks first. Let me try. Actually, the only reason for this cable here is that I want to share the screen from my iPhone to quickly tell you, quickly show you how the app is looking like. That's the first thing we do. Should take a second. And that's it. And that's the app. I coded this. I'm like super excited about this. It's basically green and it says magnitude is 0. This is when there is no earthquake. And then if you move it a bit, the magnitude goes up. And if you move it more, it turns to yellow. And if you move it a lot, it turns to red. And if you start it, first of all, it says like start here on this button. And it also says it's going to ask you for permission to access the sensor data from your iPhone. If you say no, it will never work. If it's running and you say stop, it stops working. It's talking about serverless, because I want to talk about serverless. It's a serverless application. So there's no web server, there's no application server. The whole application is a single file. It lives in an S3 bucket. Now, the cool thing, I guess to access the content of an S3 bucket, you can do a get operation, which is the same what your web server does to access a HTML file, and that's the principle. So it's HTML plus a bit of JavaScript that allows the single-page web application to write to a Kinesis stream. Last year, I did a demo about Kafka. I don't want to be the person who shows up here every year and talks about Databricks plus Kafka. That's why I selected Kinesis. Also, Kinesis is serverless in a sense that you never see the cluster behind serverless. So we have the serverless SPA, single-page web application. We have serverless Kinesis, and then I'm going to talk to you about serverless data pipelines and workflows. That's the thread of the talk. All right, so I'm going to show you how you can access this. And don't worry, if you go away from this page, you're not sending more data. You can already get the URL. But let me stop this here. Yep. Right. Can you scan this code if you want to participate? If you're too far away, just come closer. Like this is the last session of the day. Be relaxed and hang on. Let's. Can you all access it? That's the first question. Okay, cool. Oops. Where are we? We're here. So that's the live data. And as I said, like honestly, it's a stateful pipeline. This is why it takes more time. But the thing is, there's lots of data coming in. I'm going to show you the format and explain everything in a second. But the data needs to be cleaned up. The data needs to be transformed. And then that's the interesting thing about streaming data. We have to use time windows. So what the system does, I think it breaks it down to 2-second windows. It takes all your events, which might be, we're going to do the math later, which might be a couple of hundreds or thousands of events per whatever time unit, and then it calculates the maximum for this 2-second time windows, and then the Databricks notebook with a display function and a streaming data frame is displaying this. All right, so you're doing fine. You're playing around. I see this. We all see this. The thing is, I've done this before, like 1 week ago. We had the Data and AI World Tour in Sydney, and I've done it with a Sydney audience. And the Sydney audience, they got to 60 on average. So do you think you can beat the Sydney audience? Like, there's a couple of rules. So you're holding a piece of metal and glass in your hand. Be careful, don't throw it away. That's rule number 1. The most important rule, if you throw it, don't throw it towards me. And then there is no insurance if you break something. So be careful. And let's go for like 10 seconds. Like 1, 2, 3, go. And then we have this, typically it's 5, depending on a good day, it's 3 seconds latency. On a bad day, it's like 7. But you're getting to 30. That's not bad. And we also have some remote viewers. It's broadcasted. Come on, guys, a bit more. Is it red on your display? It is red, OK. That's cool, OK. It's not bad, that's cool. OK, I'll accept this, and we'll give it another try later on. The real question is now, what is behind all this, obviously? And I talked to you about the open source components. I actually told you already that there is a Kinesis stream. That's the Kinesis stream. There's nothing special. It's just Data and AI Summit 2023, because this is where I used it. I provisioned it with 3 shards. Maybe some of you know that Kinesis is giving you, I think it's 1,000 write operations and 2,000 read operations per shard. And it's also megabit to write and 2 megabit to read. And then you can scale with a number of shards. And but it's like the throughput is for all the consumers. It's shared with all the consumers. If you don't want that, you can switch to enhanced fan-out. This was one of the improvements I told you. So now Databricks can also use this enhanced fan-out feature, and you can have a dedicated throughput with this EFO. I'm not using it here because I don't need it. I thought you're not going to saturate those 3 shards. So that's the shards part. And then, since this is a Kafka event, one of my most, streaming event with mostly Kafka, let's say this, one of my most favorite Kafka tools is, do you know Kafka Cat, where you can get information from a Kafka topic? There is no Kinesis Cat, but there is something called Kinesis tail F, and it's the same thing. So if I run this, I see that some people are actually using the system. Maybe it's even me. Let's check this. Yeah, it's me. And then if you do more, you see this first number goes up. And you also see the data structure here. It's a simple JSON data structure. It says magnitude. It comes with a time. And then there is a UUID for your device ID generated. So you're anonymous. I don't know who's doing how much shaking. But I can dig deeper into this and show you a little bit more. And before we do this, where did my slides go? They're here. Before we do this, I want to tell you a little bit more. Let's do the math. That's also a good topic. Something I missed. If you look at the little app that you see the moving asterisk. It goes from left to right. That's the ASCII art that I coded. Like all my background is in is more, not in front end. Now with this asterisk ASCII art, I'm gonna add like full stack developer to my LinkedIn resume. So that's the cool thing. Actually, what it means is every asterisk that you see is one event that this single page web application is sending. So the math would be one event, and it goes through the whole 1, 2, 3, 4, 5 in 1 second. So it's actually 5 events per second, which makes it per minute. Hang on, it's hard to type here. And that's per hour, and that's per day. Now, I don't know, there's like 40 people, 50. Maybe my boss is asking for this number. You give me the number, 50? Let's make it 50, and let's hope for another 30 online, or maybe another 150 online. Let's make it 100. How about that? 100. So that would be 43 million events per day. That's quite a big number, and that's what I was trying to explain to you about scalability. We could reduce the latency by taking out the stateless, but if there's no state at all, we don't get to these windows. It's also not fun at all. So this is why I was just taking this compromise. Right. Good. Let's make this go away. Okay. 2 things we need to know, data engineering on the Lakehouse. One is Databricks workflows. It's the orchestrator within the Lakehouse. It's there. It's in the background. It's always there. You can use it. It's actually quite cool because it allows you to orchestrate anything in the Databricks Lakehouse. It could be a notebook. We'd never ask you to submit jar files to be scheduled. We just schedule notebooks, and that works really well. It could be a query. It could be a dashboard. It could be DBT project. It could be DLT, which is the Databricks way of building data pipeline. It could be anything. So anything in the Lakehouse you can schedule, you can orchestrate with Databricks workflows. It is kind of serverless, although only now we talk about serverless workflows, but the control plane, the back end of workflows that makes the whole thing run is always there. It's 4.5 nines of availability. It's like tens of millions of containers that we schedule every day. There's a really cool blog posting out from Yippee Data where they talked about, they used Airflow before in combination with Databricks. And then they said, look, all this switching back and forth is not really worth it. And if we had workflows, Databricks workflows in 2018 when we started, we would never have started with Airflows. It's a cool story about why and how they migrated. And then you define the control flow. Should it run? Typically, it could be just a sequence of 2 or 3 steps. It could run in parallel. You can have if-then dependencies, etc. And then there's various kind of triggers. You can trigger a workflow when a file arrives. You can typically trigger a workflow like every Friday afternoon, etc. Whatever you expect is in the workflows. And it's serverless now, and that's actually pretty cool because now the part that is executing your jobs is serverless. Before you could define a cluster. It could be a jobs cluster, which is cheaper, or it could be a normal interactive cluster. And now this is in preview. If you think about serverless, when serverless kicked off, when was it? 2014 or so with AWS Lambda functions. The promise was this instant scalability. It scales down to 0. You only pay for value. That means you're never paying for an idling cluster. That's all cool, and that's all still very technical. Now, we do the same thing, but what we give you with workflows is actually one only setting that you choose. You decide, do you want to run your workflow as soon as possible, or do you want to run it as cheap as possible? And that's actually a cool decision. That's something that really gives you business value, which I think is less technical than this, instant scalability. Okay, that's the workflow story. The more important story for here is Delta Live Tables. It's the Databricks way of making data pipelines. It's an abstraction on top of Spark Structured Streaming, because a lot of people say, hey, I could do the same thing with Spark Structured Streaming. And I always tell them, look, guess who's the initial creator of Spark Structured Streaming? It's the same person who now develops Delta Life tables. So looking back, like, I don't know, is it 8 years or 10 years almost? The same person says, okay, we did this like 10 years ago. Now, with everything we have now, how could we improve it? And the promise is, it's simple. It could be plain SQL code that you use to define declaratively a data pipeline. So it's just high-level SQL code, which works really well. It could be Python if you want. My example is still using Python, but today it could even be written in SQL. The big distinction between, you can basically choose. You can do everything in Python, and for a long time you could do almost everything in SQL, but if you wanted to ingest from a message bus, such as Kafka or Kinesis, you had to write the ingestion part in Python. And now there is also a SQL way of doing that. So in SQL, you could say select star from, and then it's a function that is called read Kinesis, and it's available today. Read Kafka will come shortly. The other cool thing is, talking about serverless, it automatically manages your infrastructure, so the clusters are created for you automatically. We have something called expectations, where you kind of prevent from bad data flowing into your system, into your tables, and it works for batch and streaming. We always overemphasize the streaming part, so now sometimes people come to me and say, does it work for batch? I'm like, yeah, of course it works for batch, but the exciting thing is it works for streaming. So what you've seen right now, all your data from your phones was going through a streaming DLT pipeline. Okay, and typically what we do is we ingest either from a bucket in S3, which could be cloud files, could be any other folder from Kafka, from Kinesis, and it's a streaming table. That's anything. Let's say like this, if you stream to a table, it's a streaming table, which is a component within DLT, and that's typically what we use for ingestion. Streaming here means it keeps state. It works incrementally. So people always say, if I use streaming, it's more expensive, isn't it? The answer is no. First of all, you could schedule that pipeline to only run every Friday. But then, even if you're running it continuously, it will remember state. So if you have to backfill, or if you have to go back and restart the pipeline, it will remember how many messages it has read already. So if you're ingesting like 1 billion rows and then 17 more, it will remember you already had ingested 1 billion rows, and the next run of the pipeline, it will automatically only ingest the 17. And then we also have the materialized views, which are more for complex transformations. It's something you would build to have a table for a dashboard. There is also serverless DLT now, which comes with more optimizations. So we can optimize the pipeline execution. We can overlap the micro batches, etc. All right. So typically, I'm doing like audience left-hand side versus right-hand side. But today, there are not that many people. We can do the whole thing again at the end of the presentation. Actually, I need to check the time. It's good, very good. All right, so let me show you some code. How about that? You've seen the Kinesis stream. You've seen the live output coming directly from Kinesis. So where we are is here. This is your iPhone or your Android. It goes through Kinesis. It's a messaging system. I told you we kind of connect with, Kinesis, Kafka, pops up, any of these. So whatever is available in the Databricks runtime, we can use it here from DLT. DLT is the preferred way of doing data pipelines because it's the easiest way of doing data pipelines. It works for batch and streaming. You choose if you prefer Python or SQL. Having done that, in the data pipeline, I increase the quality by dropping the rows I don't need, dropping the bad rows, and dropping the columns I don't need. And at the end, I come to something which we call gold table. It's called medallion architecture. Starts with bronze, goes to silver, and then gold. So gold is what I want to use downstreams. And my gold table has the name sensors. And with a sensor table, I do this streaming data analytics that was showing you those bars. And then I can create more, notebooks, can use Plotly for 3D visualization. I can use Databricks SQL for dashboards. I can use workflows to create a workflow on top of that. And I could actually even share the data to another system, another platform, another cloud. And what I'm often doing, not today, because probably we don't have the time, my demo is running on Databricks on AWS, and then I share using delta sharing. I create one share. It's actually literally in SQL. The command is create share. It's creating a share. And then you add a table to the share. You give privilege for the system to access it. And then you have a foreign system, maybe just running Google Colab and Pandas, and you can access the data, or you can access it from Spark, from EMR, from any other system, any other cloud. It could be Tableau, it could be Power BI, whatever. So that's the whole flow of the demo. And then let's look at some code. I see you're still doing stuff. That looks good. The code for showing this here is actually Spark structured streaming. So that's the easy part. What I do is it's Spark. Can you read that? Let me zoom in a bit. It's spark.readstream format delta, because at this point it's already a delta table, and I tell you how we get to this delta table. The table name is sensor, and I'm using a watermark for 3 seconds because I don't want to keep the context, the state in this stream forever. I group it in by time, and I make 1 second windows. And within these 1 second windows, I want to average all the incoming events. And then I order these windows descending way, and I display the last 31. And this is what gives us this live display that is scrolling through here. Okay, now let's look at the data pipeline. The data pipeline is here. Where is it? It's actually too big for me to see what's happening. It's the moving one, this one. It's called motion. And if I scroll in, you see basically ingesting here with this raw stream table. It's a streaming table. Remember, for ingestion, we use streaming tables. Then it goes on. It uses another streaming table for the sensor data. This is the data that I'm really interested in. And then I have a materialized view for global statistics, which is computing global statistics. In between, you see there's something that is not green and not moving. It's a view. So the views are not persisted to the catalog. So the whole data pipeline is also using governance. It's using Unity Catalog as a governance. And Unity Catalog allows us to apply governance, access, and actually also lineage to all these tables within the pipeline, but also more than the pipeline. And if I click on one of these tables here, you see here, that's the name of the table. It's a naming schema that has like this notation. I'm going to show you. Takes me here to the catalog. So the catalog is, where is it? Has the name demo Frank, and then it has a schema with the name motion, and within this schema, there's this table sensor. And the sensor table comes with device, time, magnitude. You've seen that. Now the fun part is, if I click here on lineage, then I see the upstream and downstream lineage. Or I click here on lineage graph, and I see the whole lineage graph. Remember, it starts with the raw stream, and then the final one is the sensor. There's a view in between, but you don't see the view because the view is not persisted, so it's not showing up here in the lineage graph. There's the global stats one here. Oops, what did I do? There's the global stats one that depends on the sensor. And let me open this. And OK. And now I can also break this down to column level. So if I say this magnitude thing, it actually flows into here, into this global stats table, because the global stats table is for all the events that ever happened, calculating the minimum, maximum, etc. So this is column level, but it's tables and column levels. If I define another table that depends on this gold table, on this sensor table, I would see it here as well. So it's from the beginning, if I ingest from a volume, I could define a volume. I would see the ingestion location, the volume. I would see all the tables in the DLT pipeline, and I would see all the downstream tables. And the downstream table actually could be a table, it could be a feature table that is used in an ML model. So you see everything from ingestion volumes through DLT, through other depending tables to ML models in one lineage graph. And that's the cool thing. And with this, I want to go back here. Actually, just showing you quickly delta sharing. If I wanted to share something, I create a share here. I think this was mine, yeah, Frank share. And to this Frank share, I added one table. And just adding a table to a share allows me to share the table. And that's the basic story for delta sharing. So that's a built-in delta sharing. If you want to share your own table in open source Delta, you can run your delta sharing server, and then the receiving side would be exactly the same. Okay, let's go back to the pipeline, and let's look at the pipeline code. This is the pipeline code. Now, I told you it could be SQL or it could be Python. When I wrote this, the only option was Python because I wanted to ingest from Kinesis. Now you could do SQL and just say SQL select star from read Kinesis, and then you would specify these parameters. So what I do is typically what you know from Spark streaming. It's just Spark read stream. And then, I should zoom in a bit. The fun part is here. That's the interesting part. I use this Python decorator DLT table that kind of creates this streaming table. So the equivalent of this statement here in the pipeline looks like, where is it? It's this table. So that raw stream table was created exactly with this DLT table annotation. And it's actually taking the name of the method for the table, unless I define it otherwise. I could say here comment equals, name equals, and override the name of the table. And it's using this myStream, which is doing a Spark read stream kinesis. And because it's reading from a stream, automatically it's a streaming table. And then the next one, remember, that was the view. And I defined this view here as create view. Probably you know that if you ingest from Kafka, you have a blob and you need to map it to a schema. Here I map it directly in the code. Same thing for Kinesis. I need to map this. This is also why I thought this mapping is not so important. I don't need to persist this. This is why I created a view. And then the last one is the sensor table. Again, it's a streaming table because it says DLT read stream. And then I have this global stats table, which is not a streaming table. Look here, it says DLT read. And if you look at the pipeline, this is sensor, it's a materialized view. So the last one, this is a materialized view. Okay, and that's the pipeline. And that's the whole code for the pipeline. If you write this in SQL, it shrinks even more. It's like 2 lines per table. As I told you, I'm more a backend developer doing Java and Python. But if you ask me the preferred way of creating such a pipeline, I would use SQL. And then people say, that's interesting. It's a bit like, one of these 7 years ago, we had all these conference talks about domain-specific languages. And I always said, guess what? The best example for domain-specific language is SQL, no? Because it's purposely built for data querying and data access. And this is also why I think SQL is the best solution here for creating declarative data pipelines. There's a bit more fun. Remember, I was trying to explain you this first streaming table here. And do you have a good feeling? Do you think you know what it's doing? If you don't, and if you're here you can click on the assistant. So the Databricks assistant here, it can help you. If you just click on this and you say, explain me the code, I'm always tempted to say please and thank you, but I don't think they care. So if you say explain me the code, it says, this code uses the Spark SQL API to read from Kinesis. It creates a DLT table with this name. So it knows the context. It understands the context. And that's the cool thing. So the assistant is a LLM, but it also knows the context and the schema and everything from the Unity catalog. So the Unity catalog is the perfect way of augmenting the data that is coming from this. And it says Spark read stream, blah, blah, blah. And the fun thing is, it says there's two variables, reset and PA-sync. They are not used in the code and can be removed. And that's actually true. I was playing with them. What we can do is we can define those tables as being resettable or not. Sometimes we ingest from Kinesis, and then the data is ingested from Kinesis. The data in Kinesis or in Kafka expires. And then if you reset your pipeline, you want to lose all the data. And this is one of the settings to prevent that. And I was playing with this, and I removed it, but I still have those two variables. And this is why it here says, look, you could basically remove them. That's a cool feedback. Something else I want to show you is, we should look at this, because this is you guys. That's a histogram over all the client IDs. That means all your iPhones. And if I run this, it's still running. It's a streaming ingestion from the sensor. It's grouping by device, and then giving us the magnitude. So we should see all the iPhones from you guys and see the magnitude of like who did how much shaking. Let's run this. And I have a few more other notebooks that I can show you. One is plotting. Let's run this also. It's doing a 3D plot. And I think the one with the histogram just came back. Look at this. That's cool. So, someone did really well with 182. When I did this at the Data and AI Summit in San Francisco, one guy, he was throwing his iPhone in the air like 2 meters and then catching it again, and like beating the system like this. I don't know if it gives you a big magnitude. I think the small shakes, they give you the highest magnitude. But you see, this is dynamically updating. It's a visualization that is running all the time. The cool trick here, again, is displaying a streaming data frame, a Spark data frame. That is based on a streaming table. That's just standard Spark structured streaming. Where's the other one? I ran the other one. Can get here. That was the plot that I wanted to show you. So the plot has good days and bad days, and you're going to see in a minute what I mean. Okay. So these are all the device IDs, and this is the time. And this is what we did. So you see, if we sort it by this, basically all the shaking leg, when we did the demo together, was here at this time. Don't ask me about what time that is. It might be German time. This is how I feel, like midnight. And these are the device IDs. So if I do it by this, you could actually find out the maximum, and then it depends a little bit on how I sort it. Isn't that cool? Okay, last thing I want to show you is the workflow. If I click on workflows, I define a workflow that looks like this. Basically, what we give you is this matrix view. So every workflow execution looks like this. So they're all green. It's all good. It's a 2-step workflow, step number 1, step number 2. This one is not green. This one was September 18th. This is like the day before I had the presentation in Sydney. You know what happened on that day? There was a huge AWS outage. So that workflow took much longer than it should take. What I did with this workflow, actually, it looks like this. It's updating a dashboard, and it's creating a heat map, and it failed in the second step. Typically, what I can do is I click on this notebook that is creating a heat map. I fix the notebook, and then I click on repair and rerun. And then the workflow would just execute the failed nodes and all dependencies. So if the first step, now this is updating a notebook, that's happening really quickly. But if the first step was an ETL ingestion task that takes like half a day, it would automatically only run the second task in this workflow. So these are all the runs. And I already told you that one went wrong. And if you click on jobs, you see the jobs. And this is what I wanted to show you, the definition here. So job details. It's actually using a serverless data warehouse, which is updating the dashboard. I'm going to show you the dashboard in a second. And then it's using serverless workflows. That means the jobs are executed on a serverless, well, I shouldn't say serverless cluster, but you know what I mean. And then I had a job parameter that says, give me a warning if it takes longer than 10 minutes. And that's exactly what happened here. That's the 10 minutes line. And because this took longer than normally, I got this warning automatically. Right, I think we're just in time, and this is about what I wanted to show you. Let me go back to my slides. Maybe just, so we covered all this and all this. The last thing what I want to tell you is we have a new demo center. So if you like this demo, if you want to see the same, like a shorter recording of the same use case, we have it in the demo center. If you like to play around with this use case, I have the notebooks on GitHub. It's actually not a canned demo. So if you want to try something easy, go to the demo center. We have a lot of canned demos where you just do a pip install. You see the dashboards, you see the DLT pipeline and everything, which reminds me, I forgot to show you the dashboard. I'm going to show this as well. Let's go to the dashboard. Where is it? So the dashboard, I should see from easiest way from here. If I look at the tasks, so that was the update dashboard task, and it's a SQL dashboard. That's the dashboard. Looks like this. The dashboard is based on this global statistics table, which says, hey, during 1 hour, we ingested 22,000 events. Maximum magnitude, one of you guys did 182. On average, we did 9 because actually there's lots of zeros. So the average is like really low. And this is the standard deviation. Anyway, that was just dashboard that I missed to show you. So if you want a canned demo with a simple pip install, we have all kind of use cases, customer churn, DLT pipelines, actually even training chatbots. Simple pip install, you have the full thing running in 1 second. We have video demos. And we also have these click-through demos that make you feel like you're working with the product. So you click through DLT, you see the UI, but there's no backend. It's just a mock-up. And that's it. There's a few more resources. I'm going to share the slides with you. If you have technical questions, we have a community.databricks.com. That's the best place to ask technical questions that require a little bit more context, like if you want to give us a JSON file or whatever. And with this, I want to say thank you. Thanks for being here. Last session of the day, I think. You've been a great audience. 182 is actually amazing. Hope you liked it. Please rate the talk. If that's the best streaming data that you've ever seen today, please rate it. If not, then up to you. I'll be around for more questions. Thank you.